radicals. If there's a negative underneath, you pull out your I. We added, subtracted, and multiplied. So we have a few things remaining. The first is dividing.
I actually have a question.
Okay.
How come we can't just change our I to its negative, like, radical form? Like,
So
we keep pulling it out and stuff. Why can't we just change it and add it in with the?
why can't we just have the square root in this
Yeah.
one? Because you can't. It's not proper notation to leave a negative under a radical. So it's really just a notation thing. Yes, these are equivalent. The rule is, though, always write an I in this place. Do you guys remember from Algebra 2 what we did if there was an I on the denominator? Multiply. Okay, on this one, I could just take top and bottom times I. Note in a fraction, if you're not changing the problem, whatever you do on the top, you do on the bottom as well. So then on the top we have a 3i. Over the bottom is I squared. I squared is -1. So 3i divided by -1 is -3i. We are asked to write this in standard form, a plus bi form. I don't have an a on this one. There's no real number part, so that's my final answer. Let's look at b. If I just multiplied my I, let me ask what happens there. On the bottom, you would have to distribute, and so you would end up with a 5i minus I squared. Now, I squared turns into -1, but did it get rid of the I? No, it just moved it to the other term. So I can't only multiply by the I on this one. What will we have to do instead?
Multiply by the opposite, so 5 plus I.
Yes, the conjugate, 5 plus I. Okay, these are two terms, so we are going to have to FOIL all this. So we get 15 plus 3i plus 10i plus 2i squared. On the bottom, if you FOIL, you get 25 plus 5i minus 5i minus I squared. All right, let's start cleaning this up. So this is kind of turned into one of the multiplication problems, like what we were doing yesterday. And we knew yesterday every time it turned into an I squared, we could simplify this. So 2i squared is -2 plus my 15. 3i plus 10i. Okay. On the bottom, the 5i and -5i cancel. So I have 25 minus I squared.
So
It'd be like 25 minus -1.
that's 26.
26. Okay. Now, I did ask for standard form, a plus bi. If it's true standard form, you can't leave it in a fraction like this. We have to break it up. So this is like 13 over 26 plus 13 over 26i. Can you reduce those?
13 and 26 carry 1.
So we get 1/2 plus 1/2 I. I do want you to go ahead and separate those fractions. Don't leave it as like 1 plus I all over 2. Separate them into a real term plus an imaginary term. All right. Questions on that one? I'm going to give you guys a couple.
Multiply 9.
Multiply 9 by top and bottom.
No. Somebody raise their hand. Okay. So if you did that, you get 45i over 81i squared. So that's 45i over negative 81. Divide by 9. So you get 5i over negative 9, or you could write negative 5/9 I.
But you didn't have to pull out 9i, you just had to pull out 9, right? I mean I.
You need to reduce.
But in the beginning, you could just multiply by I.
Yes. So the second option, we multiplied by 9i, and we had to reduce later on. We could have just multiplied by I on top and bottom. So then you would get 5i over 9i squared. So that's 5i over negative 9, which is the same thing, negative 5/9 I. So this one we could get there either way, as long as it's just one term. Remember, terms are separated by addition and subtraction. As long as there's no addition or subtraction, all you have to multiply by is the I. Now, if you multiply by the whole thing, that just means you have to reduce your fraction later on. It's not a big deal. Okay, B. What do we have to do on this one?
Minus.
Right. Because it's two terms, we have to do the conjugate. So we're going to FOIL on top and bottom. So that gives me a 16 minus 12i minus 12i plus 9i squared. On the bottom we get 16 minus 12i plus 12i minus 9i squared. Alright, combine like terms. 9i squared is the same thing as what?
Negative 9.
So negative 9 plus 16 would be 7 minus 24i. 16 and negative 9i squared, that would be 16 plus 9. And the 12i's drop. Okay, can I leave it like that?
No, you have to separate them.
Do they reduce?
No.
7/25 minus 24/25.
If you put like the I on like either the 24 or the 25, or do you have to put it like outside the
You would need to put it either on the top or out to the side. Don't put it on the bottom. Yes, ma'am.
So the plus 9i squared and the bottom, I cancel those? I not do that?
You can't because there's multiple terms because of the addition and subtraction. If things were multiplied, then it would be legal to cancel them.
You just broke them off.
Yeah, it's a serious law. Break that one.
All
All right. Any other questions here? Do we need more of those? Okay. In the next section, we're going to start talking about quadratics, and we'll use the quadratic formula to solve things. And so we might come up with some expressions that look similar to these. So I want to make sure we know how to simplify them. Okay. So on this first one, if I had to simplify this, what would I do?
First, see if 128 is a positive number squared.
What could you break it into?
That's 2.
Yeah. 128 divided by 2 is 64, and 64 is a perfect square, isn't it?
Or you could do 4 and 32.
And if you did that, that also works, but then 32 can be broken down again into 16 too, so you'll have to reduce it twice. So you can get there either way. So I have negative 8. Since there was a negative under here, what's going to come out? An I. Square root of 64 is 8, so I have negative 8 plus 8i radical 2 over 4. Remember, if I want standard form, we have to break this up. Put each one over our 4. So negative 8 over 4 is negative 2. plus you can reduce the numbers outside the radical. So 8 divided by 4, you could write 2I radical 2. Is that one okay? There's yours to try. Kinsey? Yep. And since it had the negative, you have to pull out an I. Square root of 100 is 10. Divide by 5. So if we separate that, this time we got positive 2 plus 2I radical 2. Very creative in my problems. Answers are so different. Alright, is this part okay? One last topic that we need to talk about. We are going to look at powers of I. So, we know that if you have I squared, what does that turn into? Negative 1. So if I had like I to the 4th power, think about, that's the same thing as I squared times I squared, isn't it? It would be a positive 1. If I gave you I to the 5th, you could break them into I squareds, but then you still have one more I. So you have the negative 1 times the negative 1 times an I, which is negative 1 times negative 1 would be positive 1. So it would just be I, wouldn't it? 1 times I. So when we have these powers of I, if I gave you, I to the 5th, we could write that out and figure out an answer. But if I gave you I to the 300th, I don't think any of us want to spend the time to write all that out. So our strategy is to break it into groups of 2. So for instance, if I said like I to the 7th, my question is going to be, okay, how many groups of 2 can I form? How many I squares? There would be 3. Are there any left over? 1. You can always do a quick check here. If I multiply those, that gives me a 6 plus 1 is 7. Okay, I squared is, so I have negative 1 to the 3rd power times I. Basically, negative 1 to any power is either going to give you 1 or negative 1. If the power is even, it'll be a positive 1. If the power is odd, it'll be a negative 1. So this is negative 1 times I, which is negative I. The only possible answers you are going to get on these problems are negative 1, 1, I, or negative I. So 4 possible answers. Positive, negative 1, positive, and negative I. So let's work through a few. If I said I to the 15th power, our strategy is to figure out how many groups of 2 can we form. 7, because 7 times 2 is 14. I need 15, so we have 1 I left over. Okay, I squared is negative 1. Negative 1 to the 7th would be, and negative 1 times I, negative I. B, I to the 33rd power. Okay. 2 times 16 is 32. I need 33, so there is 1 I remaining. I squared is negative 1. Negative 1 to the 16th is 1 times I is just I. So far, so good? Say I said I to the 22nd. So it'd be I squared to the 11th. Any left over? No. I squared is negative 1 to the 11th. Negative 1. Alright. I'm going to throw a curveball at you this time. This is I to the negative 12th power. You could. There's a couple ways you could do it, but that would be one option. What does a negative power do? Puts it on the bottom. So we could just make it 1 over I to the positive power. What is I to the positive 12? So how would I break that? I squared to the 6. I squared is negative 1/6 is 1, and 1 over 1 is 1. Let me do one more negative. Say I gave you I to the negative 51st power. Okay. So what does the negative do? Okay. So if I want to break down that I to the 51st, see, I squared how many times? 25. Any left over? Because this is just 50, so we need one more I. Okay, so I have a negative 1 to the 25th times I. What is negative 1 to the 25th? So I have 1 over negative I. Can I leave my answer like that? This one kind of combines the other strategy. You can't leave the I on the bottom, so you have to take top and bottom times I. Because you had a negative 1 here, from the negative 1 to the 25th. Do you see that? When you did the negative 1 to the 25th power, since 25 is odd, that's still a negative 1. So that's why it's a negative I down there. So then if we multiply by I on top and bottom, negative I squared would turn into positive 1, so we just get I. So on those, if you have a negative power, you might have to end up getting the I off the denominator at the end, but your answers every time, 1, negative 1, I, or negative I. Any questions over anything we've covered today? So you have the rest of the hour to work on that Math Excel assignment. It's due tomorrow, and we are starting the next section.